Today is 31-1 and we're going to be looking at special triangles. And so we're going to recall these special right triangles, which is the 30, 60, 90 and the 45, 45, 90 triangle. Now before we do that, let's just do a quick brief review of the Pythagorean theorem. For any right triangle, you have two legs and a hypotenuse. The sum of the square of the two legs equals the square of the hypotenuse. And so we get this formula, a squared plus b squared equals c squared, where these are going to be the legs, and this right here is the hypotenuse. Now in referencing to this triangle here, these two values right here, those are the legs, and that is my hypotenuse. So I can find my value by doing a squared plus b squared equals c squared, and then this is 25. And so taking the square root of both sides, I get 5 equals x. Now this is actually a special type of right triangle in terms of the Pythagorean theorem. We call this a Pythagorean triple. And the reason is because these three numbers here are rational numbers and they're not any form of square root or anything like that. Now what's important about these Pythagorean triples is that it's much easier for us to find what the missing value is because it is a Pythagorean triple. So like me knowing what this Pythagorean triple is, I can immediately say my y is 12 because the Pythagorean triple is 5, 12, 13. Now you can verify that. We can say a squared plus b squared equals c squared, and we can solve for y, so we minus 25 on both sides. And so I get y squared equals 144, square root both sides, and I get y equals 12. And so that kind of like verifies my conclusion there. Now I encourage you guys to memorize the Pythagorean triples, and you can go on Google and take a look at some of those Pythagorean triples just because it can make things a lot easier and quicker. Now they can also be ratios of each other too, so I can say 6, 8, 10 is also a Pythagorean triple. Now these are the two special triangles that I was talking about. We have a 45, 45, 90 and a 30, 60, 90 triangle. Now these triangles have a ratio where for the 45, 45, 90 that my two legs are equal, and whatever my leg is times root 2 is my hypotenuse. So if I said like my t is 5, you know, this would be 5, this would be 5, this would be 5 root 2. The 30, 60, 90 triangle, the shortest leg, we say that that's t. That means the longest leg is whatever the shortest leg is times root 3. And then the hypotenuse is whatever the shortest leg is times 2. And so we can use these special ratios to be able to figure out what the values are of a triangle. So let's just say here, I wanted to find what my missing sides are. Well, my special right triangle, we know 45, 45, 90, this is t, this is t, this is t root 2. I can set these equal to each other. So I can say 7 equals t, x equals t, and y equals t root 2. Well, in this establishment here, because I said 7 equals t, I can plug in t in for those other values, so I can say x is 7 and y is going to be 7 root 2, which is going to be my answer. For this one here, I can find what my x and y is. I have to compare it to my 30, 60, 90 triangle. So we said that's 60 and that's 30. Well, we said this is t, the longest leg is t root 3, and this is going to be 2t. So that means I can make the statement x equals t, y equals t root 3, and 10 equals 2t. And so solving for each of these, divide both sides by 2, I'm going to get t equals 5. And so now that I've compared this problem, now I can take this value and I can plug it in back into the other problems to be able to complete the triangle. And so I'm going to get x equals 5 and y equals 5 root 3. So going over these two triangles, just kind of like talking about the steps there, the first thing that I did here is I compared the problem to the key, and so on both of those triangles that I did, that's what I did here. Then step 2, I took t and I plugged it into the rest of the triangle. So once I established that a relationship, right, and compared everything to the sides, I got what t was, which was here, and then I plugged it back into the other values, and that's how I got what my x and y are. Looking at this other problem here, my first step, I need to compare it to the key, and so this is t, t root 3, and 2t. So I can say that 5 equals t root 3, x equals t, and y equals 2t. So solving for each one, divide both sides by root 3. Immediate t equals 5 over root 3. And so now I can take this and I can plug it back in to both of these. And so I'm going to get x equals 5 over root 3, which if I wanted to rationalize it, that's going to be 5 root 3 over 3. And then here I can say y equals 10 over root 3, which is going to be the same as 10 is root 3 over 3. So going over this last problem here, asking us to find what this unknown and missing side is, what I need to do is I need to go through and I need to label certain components of it. Well, I know that this is a 30, 60, 90 degree triangle, and this is a 45, 45, 90 triangle. So that means the ratios still apply. This is being my hypothetical 2t. And so if I know that that's going to be 2t, this is now going to be 15, which makes this 15 root 3. Well, if this is 15, this is also 15, and then so this is going to be 15 root 2. So immediately I can say y is going to be 15 root 2, but my x, that's going to be this segment plus this segment. So that's going to be 15 plus 15 root 3. Now you might be wondering to yourself, hey, can I add those together to become 30 root 3? You cannot because of this value here. That root 3 makes it impossible for us to be able to combine them together like that. Well, this is the conclusion of our lesson. If you do have any other questions, please leave them in the comments.